Hello, boys and girls. Here we are on Chapter 2, Lesson 8, Multiply Using Mental Math. Mental math is when you do things in your head, okay? We like to teach you mental math strategies so that you are more fluid with numbers. And you can look at numbers in lots of different ways, okay? You already use mental math because, let's see, what's 2 times 2? 4. Yeah, you just use mental math, right? And this whole lesson is just talking about how you can look at a big problem like 8 times 25 times 23 and do parts of it at least mentally. Okay? So let's think about that. When I look at this, I look at the number 25, and I know a lot about 25. 4 sets of 25 makes 100. 4 times 25 is 100. 4 quarters are in a dollar, right? And then here I see 8. And I know that 4 plus 4 makes 8. So what I'm going to do is take half of 8, 4, and I'm going to multiply that by 25. Then I'm going to take the other half of the 8 and multiply that by 25. So I really just broke apart 8 into 4 and 4, right? Okay? Now, like we just talked about, mental math, 4 times 25 is 100. 4 times 25 is 100. So what do you think 8 times 25 is? 4 times 25? 4 times 25. Let's take those two and put them together. 100 plus 100. 8 times 25 is 200. Does that make sense to you? We did 4 times 25 and got 100. Then we took the other half of 8 times 25, 100. Combined those two partial products and we got 200. We have times 23 left. So we have 2 times 23 left. Now, I'm going to write that down over here. But I'm not writing 200. Look what I'm writing. Just the 2. Because I'm going to do 2 times 23 and then add those zeros on at the end. And you know that you're allowed to do that. We've been doing that a lot. 2 times 3 is 6. 2 times 2 is 4, which you probably could have done that mentally, right? And then boom, boom, boomity, zoomity, 4,600. Now, lots of people write it like that. They do 23 times 200, and then they just remember to bring those zeros down at the end. You can do that too. So the final answer is 4,600. And the strategy that we used, well, we could call it the halving strategy, halving. We took half of 8, but I'm going to go with friendly numbers because I looked at 25 as a friendly number. Okay? All right, moving on. Now, number 4 is 50 times 28. How do you guys feel about 50? That's a pretty friendly number too, isn't it? Okay? We're not going to use that strategy this time, but we do like 50. Okay? I like 50 because I know that 50 plus 50 is 100. 50 times 2 is 100. So what I'm thinking here is if I want to find out what 50 times 28 is, what if I do first 100 times 28? And then I take half of that product because 50 is half of 100. Let's see how that works out. 100 times 28, you know about that. 1 times 28 is 28, bungity, 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 comma. Okay? 100 times 28 is 2,800. So my product over here is going to be half of that. So what's half of 2,800? Well, what's half of 28? That's probably mental math too, right? Half of 28 is 14. Half of 28 is 1,400. 1,400. And if you didn't want to do it that way, you didn't have to. You can just write it down and multiply it if you want, boys and girls. But it's good to see that math and numbers have some fluidity and that you can think about them in lots of different ways. So the strategy we used here, halving, and doubling. Okay? And we actually doubled first, and then we halved the answer. Okay. Next, number 6. 20 times 72 times 5. Okay. There's no 25. There's no 100. There's no 50. Oh, I know what I can do here. I'm going to use the commutative property. Now, I want you guys to look. Do you see some numbers that can be flip-flopped so that we can do some mental math? What if we flip-flopped 72 and 5? Our problem would look like this, right? 20 times 5 times 72. Now, are you saying, why'd you do that, Mrs. Olby? Well, what's 20 times 5? If you're not sure, this is a good one to memorize if you don't know it, right? It's 100 times 72. So, what's 72 times 100? 7,200. Okay? So the strategy for that one was commutative. Oh, that's supposed to be a U. It looks like a W. Commutative property. I'm just going to write prop. Okay? Commutative property. So we just did 3 problems, 3 different ways, and we did a lot of them mentally. So just look for those opportunities, guys. Look for ways to make 100. Look for ways you can double 50 to make 100. And look for friendly numbers. All right. Down to problem solving. We are on number 8. All right, I'm going to start reading it. Number 8, right here. Section J in an arena has 20 rows. Each row has 15 seats. Okay, you got that? 20 rows, 15 seats in each row. All tickets cost $18 each. If all the seats are sold, how much money will the arena collect for section J? All right. Sometimes I like to do a little array for problems that have seats and rows and stuff in them. So it just said there are 20 rows and there are 15 seats in each row. Okay, do you see how that array works? Right? 20 rows across, and in each row are 15 seats. And then each one of those individual seats cost $18. So let's see here. That is 20 sets of 15. Now we're still trying to use some strategies here. Oh, well, look at this. What's 2 times 15? 2 times 15 is 30, and then that's actually a 20, so we're going to add on a 0. So there are 300 seats in section J. Let's go back into the problem. All tickets cost $18. So if all the seats are sold, how much money will the arena collect? So there are 300 seats, and each of them cost $18. So I'm going to write over here. here. Let's see. No, actually, I'm going to put it right here. 18 sets of 300. Now, we just talked about how you can multiply these whoppers, right? Let's go over here and do 18 times 3. Okay? What's 3 times 8? 8, 16, 24. Yeah. And 3 times 1 is 3, plus 2, 3, 4, 5 is 54. Okay? But then, of course, we weren't just multiplying by 3, we were multiplying by 300, so we're going to make that 100 times bigger. Did we answer a question? How much money will the arena will collect? $5,400. Good gravy, just for section J. Okay? All right, let's see what's next here. We're moving on to the back. Spiral review. Alex has 175 baseball cards. Rodney has 3 times as many baseball cards as Alex. How many fewer cards does Alex have than Rodney? Okay? How many fewer, how many more, how much less, how much taller, how much shorter, how much further? Please remember that that is asking about the difference. They're asking about the difference between the amount that Rodney and Alex have. How many fewer? That means what's the difference? How much bigger? What's the difference between the two amounts? And difference is what the answer to a subtraction problem is. Okay? So when you read those words, it's probably going to be subtraction. All right, so let's go back to the beginning. I have to reread, of course. Alex has 175 baseball cards. Rodney has 3 times as many as Alex. Oh my goodness. 175, that's Alex. And then Rodney has 3 times more. So whatever our product is, those are going to be Rodney's, okay? 3 times 5 is 15. 3 times 7 is 21, plus that guy right there is 22. 3 times 1 is 3, plus these 2, 4, 5. Okay, so Alex has 175. Rodney has 525. Now, I want you to look at the answers over here, guys. Those little stinkers in this math book, of course, put 525 as one of the choices for the answers. Okay? That is always going to happen because kids are like, yeah, look, I did a math problem. I must be finished. No, you're not finished. But they're trying to make it feel like you're finished. Okay, they want to know the difference. Remember? How many fewer cards does Alex have than Rodney? And remember, we're going to subtract. We want to find the difference. How many fewer? What's the difference? 175. 5 minus 5 is 0. 2 minus 7, sorry, must regroup. 12 minus 7, so we have 7 in our head. 7, 8, 9, 10, 11, 12. That's 5 fingers up. 4 minus 1 is 3. Okay, so Alex has 350 fewer cards than Rodney. Okay? All right, you guys, you're amazing. Please be sure you do all the rest of the homework your teacher wanted you to do.